Dear friends, I am Dr. Santosh Desai and I welcome you all to my YouTube channel. Today I am going to discuss how to find a particular integral when the RHS of given differential equation is an exponential function. That is when capital X is equal to e raised to ax. So first we define symbolic operator 1 upon f of t. Now the expression 1 upon f of d into x, we consider it as a sum function of x which is free from arbitrary constant, and when operated upon f of d gives x. So that is f of d into 1 upon f of d into x is equal to x. So from this one can conclude that 1 upon f of d is inverse operator of f of d. Now we know that d stands for derivative, so therefore 1 upon d results in integration. So therefore we take it as a note. So the value of 1 upon d into x is equal to integration of x with respect to x. The value of 1 upon d square into x is equal to double integration of x with respect to x. Now we consider the two results without their proof. So first one, the value of 1 upon d minus a into x is equal to e raised to ax into integration x into e raised to minus ax dx. Now the second one is obtained by this first one by replacing a by minus a. So therefore the value of 1 upon d plus a into x is equal to, just we replace a by minus a. So we get this is e raised to minus ax integration of x into e raised to ax dx. Now we consider how to find the particular integral of f of d of y is equal to x. So let us consider the linear differential equation as dn y by dx raised to n plus a1 d raised to n minus 1 into y by dx raised to n minus 1 plus a2 d raised to n minus 2y by dx raised to n minus 2 plus and so on an minus 1 dy by dx plus any is equal to x. Now the symbolic form of this equation is f of d of y is equal to x. Now let us put y is equal to 1 upon f of d into x in this equation. So therefore we get f of d, the value of y, that is 1 upon f of d into x is equal to x. So this implies, now from the previous we know that the operators f of d and 1 upon f of d are inverses of each other. So therefore the value of LHS is x and that is equal to x. So this shows that the relation y is equal to 1 upon f of d into x satisfies the differential equation, and we know that the relation which satisfies the given differential equation is called solution. So therefore y is equal to 1 upon f of d into x is solution of equation 1. Also, the term 1 upon f of t into x is a free from arbitrary constant. So therefore, we take it as a particular integral of f of d of y is equal to x. So here we got the formula for particular integral. So that is pi is equal to 1 upon f of d into x. So this is the formula to find out the particular integral. Now, depending upon the values of x, there are various methods to find the particular integral. So let us consider first one when x is equal to e raised to ax, that is exponential function. So the particular integral of f of d of y is equal to x when x is equal to e raised to ax is given by. So pi is equal to 1 upon f of d e raised to ax is equal to 1 upon f of a into e raised to ax, provided f of a is not equal to 0. Now just we understand what is the meaning of this. Now to find the particular integral when x is equal to ax, first we write the formula 1 upon f of d into e raised to ax, and then replace or put d is equal to a in the denominator, that is in the f of d, and thus we get the f of a. So if f of a is not equal to 0, this is the final answer. Now let us consider the meaning of this term. To find the particular integral, just put d is equal to a in f of d, and pi will be calculated if f of a is not equal to 0. Now the question is, if f of a is equal to 0. Now if f of a is equal to 0, then this above method fails, and that we call it as a case of failure. So let us consider it. If f of a is equal to 0, then the above method fails, and in this case the pi is given by. So pi is equal to, this is formula 1 upon f of d into e raised to ax. Now if you put d is equal to a, and that f of a is equal to 0. So in this case, first we write one independent variable, then into take the derivative of denominator only. Just listen carefully. I am saying derivative of denominator only. That is derivative of f of d only. So that is f dash d e raised to ax. And again put d is equal to a in the denominator. That is in the f dash a, f dash d. And again simplify this. If f dash a is not equal to 0, then this is the final answer. And if f dash a is equal to 0, then again we follow the same procedure. So pi is equal to 1 upon f of d e raised to ax. Now we have the term x into f dash d e raised to ax. For this term we apply the method. First we have to write one independent variable. So already there is a one independent variable. So we get x square, and take the derivative of denominator f dash d. So derivative of f dash d is 1 upon f double dash of d into e raised to ax, and again put d is equal to a. So we get f double dash of a. If f double dash of a is not equal to 0, then this is the answer. Otherwise you have to continue till we get denominator is non-zero. So the very simple procedure is there to find out the particular integral when capital X is equal to e raised to ax. So you just remember the formula, pi is equal to 1 upon f of d e raised to ax, and the procedure is put d is equal to a in f of d, and if f of a is not equal to 0, then this is your particular integral, and if f of a is equal to 0, then you have to follow the procedure for case of failure. Now let us consider the examples. Solve d cube y by dx cube minus 6 d2y by dx square plus 11 dy by dx minus 6y is equal to e raised to minus 2x plus e raised to minus 3x. Now the complete solution of given equation is nothing but complementary function plus particular integral. Now first we find the complementary function. So let us consider the given equation. Then the auxiliary equation is, it is d cube minus 6d square plus 11d minus 6 is equal to 0. Now this is a cubic equation. So to solve the cubic equation, we have to use synthetic division method. And to apply the synthetic division method, we need one root of that equation. So we find one root of that equation by trial and error method. So that means you have to put d is equal to 1. If you get 0, then we say that d is equal to 1 is the root. If not, put d is equal to minus 1. And if again we get 0, then you say it is d is equal to minus 1 is the root. And if not, again put d is equal to 2 and continue in this way till we get the 1 root. So here I start with d is equal to 1. So if I put d is equal to 1, then obviously we get 0. So therefore d is equal to 1 is one root of this equation. So therefore by synthetic division method, so let us consider. Now at the top, just write down the coefficients of d in decreasing powers of d. So we start with highest power. The highest power is d cube. Its coefficient is 1. Then coefficient of d square, that is minus 6. Coefficient of d, that is 11. And then constant term minus 6. Now to the left of vertical line, write that root, that is 1. And take first number, that is coefficient of d cube, below the horizontal line. Take the multiplication of that root and the number below the horizontal line it is 1, and write down it below the minus 6. So adding these two, we get minus 5. Again multiply root and this minus 5, so it is minus 5. Write down below the 11, it is minus 5. Adding these, we get 6. Again multiply 1 into 6 and write down below the minus 6, so it is plus 6. Adding these, we get 0. Now this is a procedure for synthetic division method. Now once you complete this, then I express the given cubic equation as a product of linear and quadratic factor. Now the linear factor is obtained by root. So here d is equal to 1 is the root. Now you shift that number to the left, so you will get d minus 1. So d minus 1 is one linear factor. And the quadratic factor is obtained by using the numbers below the horizontal line as a coefficients of quadratic factor. So the below the horizontal lines, the numbers are 1, minus 5 and 6. So 1 is a coefficient of d square, minus 5 is a coefficient of d, and 6 is the constant term. So thus one can write d cube minus 6d square plus 11d minus 6 is equal to, first we write linear factor, that is d minus 1, then quadratic factor d square minus 5d plus 6, and this is equal to 0. Now we will simplify d minus 1 into d square minus 5d plus 6 is equal to 0. So this implies that d minus 1 is equal to 0, or d square minus 5d plus 6 is equal to 0. This again implies from the first we get d is equal to 1. Now the d square minus 5d plus 6, it is a quadratic equation, and we know the formula to solve the quadratic equation. So by using that formula, here we get d is equal to 5 plus minus square root of b square, that is 25, minus 4, a is 1 and c is 6 divided by 2. Now simplifying this second term, so we get d is equal to 1 and 5 plus minus 1 divided by 2. Now take 1's plus and minus and simplify it, so we get 1, 2 and 3. Now these are the three roots of the given equation. All the three roots are real and distinct. So therefore the complementary function is given by CF is equal to, take one constant, e raised to first root into independent variable x. So we get c1 e raised to x. Just we repeat the same procedure for remaining roots. Then next constant c2 e raised to next root into independent variable, so e raised to 2x, plus next constant c3 into e raised to 3x. So this is our complementary function. Now we find particular integral corresponding to e raised to minus 2x plus e raised to minus 3x. Now we know that the particular integral is nothing but 1 upon f of d into given function. So 1 upon f of d here, d cube minus 6d square plus 11d minus 6 into the function x is e raised to minus 2x plus e raised to minus 3x. Now multiplying to that bracket, so we get the terms 1 upon d cube minus 6d square plus 11d minus 6 into e raised to minus 2x plus 1 upon d cube minus 6d square plus 11d minus 6 into e raised to minus 3x. Now we put d is equal to minus 2. So we get first term is minus 8, then minus 24, minus 22, minus 6 into e raised to minus 2x. In the second term, put d is equal to minus 3. So we get plus 1 upon, first term is minus 27, then d square, that is minus plus 9. So here we get minus 54, then minus 33 and minus 6 into e raised to minus 3x. Now simplifying the first term, the denominator we will get minus 60. So minus 1 by 60 into e raised to minus 2x, which is non-zero, plus again simplifying here we get minus 1 upon 120 into e raised to minus 3x. Now both the denominators are non-zero, so therefore this is a final particular integral, and therefore the complete solution is nothing but CF plus PI. So first I write y is equal to CF, that is C1 e raised to x plus C2 e raised to 2x plus C3 e raised to 3x, and then you just add with PI. So PI is minus 1 by 60 e raised to minus 2x minus 1 upon 120 e raised to minus 3x. So this is the complete solution of the given equation. Now let us consider one more example. Solve d cube y by dx cube minus 2 d2y by dx square minus 5 dy by dx plus 6y is equal to cos hyperbolic 2x. So let us consider the given equation. Then from the given equation, the auxiliary equation is, that is d cube minus 2d square minus 5d plus 6 is equal to 0. Now here again this is a cubic equation, so we have to use again synthetic division method. So to use synthetic division method, again we need one root. So d is equal to 1 is root of this equation. So by synthetic division method we get. So let us consider the coefficients of d in decreasing powers of d. So first coefficient of d cube, that is 1, then coefficient of d square minus 2, coefficient of d minus 5, and constant term. And write down the root to the left of vertical line. Again we follow the same procedure. Take first number as it is, 1 into 1, that is 1. Write down below the minus 2, that is 1. So adding these two we get minus 1. 1 into minus 1, that is minus 1. Write down below the minus 5. Adding this we get minus 6. Multiplication of 1 into minus 6, minus 6. Adding these two we get 0. Now again we express the given cubic equation as a product of linear and quadratic factor. So therefore d cube minus 2d square minus 5d plus 6 is equal to, linear factor is d minus 1 and quadratic factor is d square minus d minus 6 is equal to 0. Now I am going to simplify d minus 1 into d square minus d minus 6 is equal to 0. So this gives d minus 1 is equal to 0, or d square minus d minus 6 is equal to 0. So from the first term we get d is equal to 1. Second one is the quadratic equation. So simplifying this we get d is equal to 1 plus minus square root of 1 minus 4a into c, that is 1 into minus 6 divided by 2. So simplifying that square root we get, that is 25. Square root of 25 is 5. So therefore d is equal to 1 and 1 plus minus 5 divided by 2. Now taking one's plus and 1 minus and simplifying we get d is equal to 1 minus 2 and 3. Now again these are three real roots and all are distinct, therefore the complementary function is c1 e raised to x plus c2 e raised to minus 2x plus c3 e raised to 3x. So this is the complementary function. Now we find the particular integral corresponding to cos hyperbolic 2x. So pi is equal to 1 upon f of d. Here 1 upon f of d is d cube minus 2d square minus 5d plus 6 into x, and x is nothing but cos hyperbolic 2x. Now we know the formula for cos hyperbolic 2x. So just I replace cos hyperbolic 2x by corresponding formula in exponential form. So that is e raised to 2x plus e raised to minus 2x divided by 2. Now 1 by 2 is the constant term. I take it outside and simplifying these brackets we get 1 upon d cube minus 2d square minus 5d plus 6 into e raised to 2x plus 1 upon d cube minus 2d square minus 5d plus 6 into e raised to minus 2x. Now we know the procedure. Whenever there is an exponential function, you just replace the value of d by the corresponding value of a. So in the first part the value of a is 2. So replacing d by 2 in the first part, so we get, it is, first one is 8, then minus 8 minus 10 plus 6 e raised to 2x. Now in the second part we have to replace d by minus 2. So simplifying we get, first one is minus 8, then minus 8 plus 10 and plus 6 into e raised to minus 2x. Now if you simplify the first part, we get this is minus 1 by 4 e raised to 2x, and second part after simplifying we'll get 0. Now if the denominator is 0, then the method fails. And here the second part, in the second part we are getting 0. So we have to apply the case of failure for second part only. Remember, we have to apply the case of failure for second part only. So therefore, by applying that case of failure, so we get this 1 by 2 and the first term is as it is minus 1 by 4. Then the case of failure, so first we write the independent variable, that is x, and take the derivative of denominator only. So the derivative term is d cube minus 2d square minus 5d plus 6. Its derivative is 3d square minus 4d minus 5 into e raised to minus 2x. Now once you complete this, again we follow the same procedure, that is put d is equal to minus 2, and simplifying this we get. So the first part is 1 minus 1 by 8 e raised to 2x. So if I put d is equal to minus 2 in the second part, so and multiplying it by 2, we get this is 1 upon 30 e raised to 2x. So both the values are non-zero. So therefore this is the final particular integral. And therefore the complete solution is y is equal to cf plus pi. So y is equal to c1 e raised to x plus c2 e raised to minus 2x plus c3 e raised to 3x minus 1 by 8 e raised to 2x plus 1 by 30 e raised to 2x. Now let us consider last example. Solve d cube plus 3d square plus 3d plus 1y is equal to e raised to minus x. So consider the given equation. From this, the auxiliary equation is d cube plus 3d square plus 3d plus 1 is equal to 0. Again here it is a cubic equation. So d is equal to minus 1 is root of this equation. So you have to use synthetic division method. Now consider at the top the coefficients of d in decreasing powers of d. So the coefficients are 1, 3, 3 and 1. Then the root is minus 1. First element is 1. Taking multiplication of these two and right below the 3. Adding these two we get 2. Then multiply again minus 1 and 2 right down below the 3. So it is minus 2. 3 plus and minus 2 it is 1. So 1 into minus 1 it's minus 1 and the addition is 0. So therefore the cubic equation can be written as product of linear and quadratic factor. Linear factor is d plus 1 and quadratic factor is d square plus 2d plus 1. Now simplifying this we get d is equal to minus 1. Now the second term is d plus 1 bracket square. So we get minus 1 and minus 1 as the repeated root. Now here the roots are repeated 3 times. So therefore the complementary function is given by. Now first you write the term c1 plus c2x plus c3x square. One can write in the reverse way, that is c1x square plus c2x plus c3 also. Then e raised to repeated root into independent variable, that is e raised to minus x. Now consider the particular integral. So pi is equal to 1 upon d cube plus 3d square plus 3d plus 1 into e raised to minus x. Here the value of a is minus 1. So let us put d is equal to minus 1 and simplify. So we get, simplifying this we get 0. So therefore it is a case of failure. Now as it is a case of failure, so first we write independent variable x, then take the derivative of denominator, that is 3d square plus 6d plus 3 into e raised to minus x. Again put d is equal to minus 1. So we get this is equal to x into and d is equal to minus 1. Simplifying this again we get 0. So therefore it is again case of failure. Again we apply the case of failure for the step above it. So first we write one independent variable. So already there is one independent variable, so you will get x square, and take the derivative of 3d square plus 6d plus 3. It is 6d plus 6 into e raised to minus x. Put d is equal to minus 1 again. So we get minus 6 plus 6. Again it is case of failure. So once again apply the method. So we get x cube derivative of 6d plus 6, that is 6 e raised to minus x. So therefore the complete solution of given equation is y is equal to c1 plus c2x plus c3x square e raised to minus x plus x cube divided by 6 into e raised to minus x. So these are the some examples on x is equal to e raised to ax. Now you remember the procedure to find the particular integral. The procedure is very simple. That is, you have to replace d is equal to a in the denominator only. Now in the next video we will discuss how to find particular integral when capital X is equal to cos ax or capital X is equal to sin ax. For more videos please subscribe my YouTube channel. Thanks for watching. Bye bye.